So an alarm clock is a really simple type of product because number one, it's just the clock. It's a mechanism that exists that can just be installed right into the piece. All you have to do is plug it in. But the piece that it's embedded into can create all kinds of new value for this because it has to match the aesthetic of someone's room or someone's house. Therefore, there's a lot of variation necessary for this. Now, if you wanted to create a line of your own clocks, it's now possible to do so because you no longer have all of the injection molding cost up front. All you have to do is create the design, effectively upload it to something like our Etsy app, and then you are producing this product on demand. You can start out with something very simple, like this very monolithic brick. We designed it to be just a straight brick, but then we also added in a slight angle at the bottom. This not only allows the clock to be slightly facing upward, which improves the appearance of it all rather than a straight square, but it also improves the printability because this interior channel now no longer has any horizontal overhangs that would cause sagging. There's no need for supports and there's no need for special features. So there's basically nothing that could cause failure on this part, so it can be uploaded immediately and reliably and know that the part is going to come out well. So you launch that clock and maybe it doesn't sell very many, but you get some feedback from customers of things that they would like. So what you do is you go ahead and you take that initial square design and then you soften it up and lighten it up using more pastel colors in order to create a version of the clock that your customers actually want. The cost to create this change was literally just your time to create the change, but you have created a whole new variation of the product that had never existed before but is immediately available. And again, you upload it so that as soon as somebody makes an order, it comes through to a giant print farm like ours to where it can be printed and shipped to the customer. This creates a whole new aesthetic, a whole new cosmetic, and a whole new test that you can then build out your store with. Now, you're a smart product designer. You realize that customer feedback is really, really important, as well as creating variations so that customers can find the option that is most popular, because you're going to start to hit on something that people actually like. Once you found out that they like buying that rounded design, you go ahead and expand it a little bit, because customers tell you that it's not standing up well enough and they want it to be more robust so they can really slap it in the morning. So you go ahead and make an update to the design there to where it's thicker, it's stockier, and you add in a slightly more playful color for people who want it for like their kids' rooms and that kind of a thing. Once people start buying this, they start giving you feedback that, oh, I do really love that, but the square is the only options that you guys have so far. Can you make an update or make some other version? Because we don't really like square stuff in our home. Taking that feedback, you go back to your CAD software and you update the app for your clock and you create a rounded version. Again, going back to this pastel type of colors to where it's very naturalistic and easy to follow while still retaining the thicker profile so that it stands up reliably because you had learned from your earlier version of the clock. Again, also retaining the flattened backside. Basically, as the designs evolve, they improve on each other while also increasing the number of options. Now, you find that people like the round clock and they keep on buying that, so you decide to focus in on that product line and expand it rather than focusing on other new SKUs. This allows you to really take what people like and make it even better. So as part of one of those tests that you can run, like a software company changing the color of a button on a website, you go ahead and you create this green playful version, again for kids. You add a couple of little arm nubs to it, which don't need any sort of support, but make it look more interesting and more playful. You can even do this as an artistic method to kind of show off a different sort of feature that breaks up the traditional, just kind of monolithic shapes that you've had in the past. But now you give yourself a whole new demographic of the people who are originally buying the very arty, pastel-y kind of colors, now might want something more playful for the rest of the family. And sales are going well. You keep on moving these different clocks. And in fact, quite frankly, these clocks were created in a couple of hours for a YouTube video. Imagine what you could do with a concerted effort if you were really developing this product and pushing on it and taking user feedback. You could create hundreds of variations in a day, which can then all be thrown up so that customers can try and experiment and have ads run against them and find out which product is better. Rather than adjusting advertising so that the product can sell, you adjust the product so that it actually sells. It creates a much more efficient type of system. Now, finally, all of your customers have gone through. You're selling the kids versions, you're selling the pastel versions, but now you want to get a little bit more artistic rather than just a straight brick. This time you go back to kind of the flat slates and you just make it quite a bit fancier. You start to get all kinds of new cosmetics that had never been really done before with these really flat, faceted sort of designs while still maintaining the little overall angle and the main insert clock and so on and so forth. And you start changing the colors of this insert so that you can ship out a black version and a silver version and so on, working with manufacturers to refine those inserts that are custom while still maintaining the aesthetic of the clock and changing the outer housing so that it matches someone's home. Because a clock is a clock is a clock is a clock. But the outer cosmetics of it define where it'll be inside of the home and who will actually want to buy it. But as time goes by, you're able to create more and more complex types of shapes that give you more of a competitive advantage because you as the designer know how to create them, while at the same time still creating a large variation. And then again, as customers give you feedback, you're able to change it. You don't have molds. You don't have to spend $50,000 every time to create a new version of the thing. All you have to do is create the new version of the model. You upload that to something like our Etsy plugin or the API, and then whenever somebody makes an order, it is printed and shipped directly to them, or you can order small bulk batches in order to just get them knocked out quickly and do the assembly yourself. That way you can also control packaging and other items as well. But 3D printing has opened up this entirely new opportunity to where you can create all types of new products without the cost of creating products. It's like writing a new app. The app could blow up, go viral, and sell 1 million copies. And since you have a giant print farm supporting you, you can make 1 million copies. But you can also just create hundreds of variations so that people who want a specific type can get a hold of it and find a product that had never existed for them before. Now, an iPhone is a beautiful piece of product. Regardless of what you feel about any other part of it, it is a beautiful object. And the thing that's frustrating about it is that even though this is amazing, much of the accessories around it are terrible. For example, this case. This case is a rubberized, ugly, terrible thing that would make Steve Jobs turn over in his grave, but it's required for protection of it. Likewise, you require some sort of charger, and many of the accessories out there are some piece of black plastic. And this is where 3D printing can really shine, because 3D printing can create a large number of options so that people can find something that matches their taste so that it can match their overall lifestyle. 3D printing can create different colors, different shapes, different aesthetics and functionalities without high upfront molding costs. So in this video, we're going to go through how to design a number of different iPhone stands. Now, the first thing with all of these iPhone stands is that, number one, functionally, they have to do a job. They have to charge. So cutting off the top slot so that it's able to sit at a beautiful angle on all of these is one of the main factors with all of them. But then from there, you go ahead, cut a slot for the wire to come out, nice small groove in the back. With this type of a design, the main thing to make sure that it is manufacturable is to make sure that there are no overhangs and that bed adhesion is minimized, though not to the smallest degree possible. In the bottoms of all of these, we made these conical cutouts. What this does is ensures there's no overhang, but makes sure that both the part sits more level on a table because you don't have to worry about any sort of warp over time, and you have this outer ring so it can easily be auto-ejected. So if you want to make 10,000 of something like this, it's very easy. We started off with a very simple cylinder, and the simple cylinder is great, but it shows off a lot of surface finish. So sometimes if you don't want the layer lines, you might apply a texture to the outside like this. This creates an evolution of a part like this, where you use the ribs and you can even make these smaller or turn them into spirals or anything else along those lines. This one, we demonstrated what it looks like to have the flat bottom versus the conical. And with the flat bottom, you can see the dangers that you can have. You can have contamination, staining, bed connection that just isn't quite right. So there is a lot that has to occur to make that bottom surface look perfect, whereas there is much less that has to occur to make this bottom surface look perfect. Now, expanding from there, you can go ahead and add different shapes, create different colors. Using the capabilities of printing, we're able to do metallic-like colors. So this hexagonal design is actually able to work really well, where you have the charger embedded in there and the phone MagSafes right onto there. We also added the texturing to the outside to again make it look very premium, and you have this wonderful object that could sit on a nightstand or in a hallway when people come in, and they can just snap their phone onto there and the things start charging. But you can go even further than this because you're able to create this really wonderful shape. We went for a bulb with this rounded shape. This is wood-filled PLA, and with wood, you're able to get a lot more out of it. And the real advantage of printing is that you can create all of these variations, add them to an e-commerce store, and then based on what people purchase, you can expand that design. If people liked the basic cylinder, you can expand to the different colors or start expanding the basic concept of that basic cylinder, and you're effectively A/B testing different types of products. So this charger is a great model of how to do design of products for 3D printing. You have zero upfront cost effectively. You can use giant print farms like ours to get the scale and the fulfillment, and then you're able to focus on the actual product design to get something that is really beautiful and something that your customers really want, and you can chase down all the options that people could have without inundating them with choices by saying, oh, customize it, put your name on it. Don't do that, that's terrible. But you can create a large SKU count so that anyone's individual taste can be matched by whatever it is that you're creating. And with accessories like iPhone chargers, there are a lot of new variations needed, and when the new iPhone or iPad or whatever other type of device comes out, there may need to be recreations of these accessories in order to be compatible with the new version. This applies to tools, phones, machines, whatever it happens to be. Accessories have to continuously evolve and be very quick to change, which is exactly what mass production 3D printing is really good at. If you would like to get access to these files and sell them on your Etsy store or on Shopify or anywhere else you want to, heck, put them on Amazon, you can go ahead and get these over at Angled. And if you would like to sell them on your Etsy store without having to run a 3D printer, we have our Etsy plugin that lets you have access to our entire print farm to print and ship any of the items that you have that are ordered. So it's a really good way to scale up your operations. But if you just want to get a cool charger for yourself, go ahead and grab the files and you can print them yourself. The manufacturing concerns with making 3D printed lamps. So we recently released a lamp puck on Teleport so that you're actually able to create your own lamps and have them printed and shipped to customers. But there's a lot of concerns around the design of 3D printed lamps that we'd like to go through in this video around how to design this without having to rely on things like slicer settings in order to make sure that you have a good result. Because you don't always have control of the slicer settings, and as more and more products are made on demand, it's really important to make sure that your CAD and your 3D modeling is what enables the lamp to look amazing. So let's go ahead and dive right in. The very basic information of all of this is to just make sure that you have the item shelled. Make sure that it is hollow and has a wall no thicker than about 1 millimeter. This makes sure that you actually have pass-through regardless of what the color is so that you can see the lamp glow, and you still have something robust and reliable that can be shipped without it breaking. This is not traditional vase mode. All of the parts printed through Teleport go through just a standard printing profile, which means that it'll go around the outer edge. So you have to actually shell the part. You can't just upload a monolithic ball and expect it to turn into something that's viable for a lamp. Vase mode is also very, very delicate. When you print that sort of way, you end up with parts that are weaker. Whereas if you print with traditional profiles, you can create something that's more durable, even though it's thin-walled. This also allows you the ability to create single-piece monolithic lamps. Mini lamps are built with a base and a top. It's very common to make it like that. But when you're using a standard single profile throughout the entire lamp, you're able to merge the shade into the base. So the base is able to have features designed into it in order to make it solid and rigid and reliable and able to mount the puck inside of there. And then the rest of it can be thin where you want it to. And this creates some really interesting situations that we'll get into a little bit later on because you can better control where the light ends up. So whenever you're trying to print something like this, just make sure that you have a 25% infill, 0.2 layer height, and a 2 wall thickness, and you will be ready to test out and prototype for something like Teleport. So the one sneaky part about all of this is the seam. The seam itself does still appear. The seam is set to the rear of the part when it's uploaded to a service like Teleport. But now you have to design for the seam. And now many of the simplest ways to get around this are to use something like texturing in order to hide the location of the seam so that you have still a very nice matte general surface finish rather than a pure 3D printed finish. And that also helps to get rid of any other sort of artifacts that might come up during printing. So if you design in a texture to the part, that's a great way to deal with the seam. Or if you design a really jagged lamp with like a lot of features on the outside, that's also a great way of dealing with the seam so that it looks beautiful when you finally light it up. Now, designing with bases is not a bad thing, and in fact can create a really cool aesthetic because you want contrast between the different parts. And you're able to upload 2 separate parts and have this printed in one color and this printed in another color, all you want, and of course include the puck light. But what comes from this is that, again, you're restricted to a very particular profile. So the base will have its own appearance. Now here you can see the inner 25% infill, which can be a challenge on that because you're dealing with the opacity of the base. But the way to get around this is actually design in internal structures inside of there. You could basically do slats all along the outer side, which create walls inside of walls inside of walls. Basically a 0.2 millimeter cavity inside of there that's basically like another sleeve inside of that and another sleeve inside of that, so that you create the layers of an onion. That way, again, you're no longer dependent on slicer settings in order to create a reliable part. Now, this circular shade brings up a really interesting situation because it has a uniform thickness all the way around. It is 1 millimeter thick all the way around, including on the top, which means that now you have this lighting artifact because the top is a perfect overhang. It's totally flat and a printer cannot print that. Even with support underneath there will be some amount of distortion on something like this. So how do you avoid those types of situations? Well, a few subtle ways of doing it is to actually vary the thickness of the inside so that it starts out as 1 millimeter, it stays 1 millimeter, but then it starts to get a little bit thicker up at the top so that there's more meat there so that you don't have one layer fall away and you get this bright spot at the top that looks a little rough and nasty. Again, also using texturing applied to this can also help to disperse that so that you have kind of a thicker outer wall that breaks up these types of artifacts. That way you don't have to worry about the print being absolutely immaculate because people will see everything on this orb. You can use that texture to diffuse it around and make it look really, really beautiful. Another way of dealing with these overhangs is to eliminate them entirely. Here in this case, this is a single monolithic print printed entirely with the same profile all the way through, but of course it's transparent through here and opaque up here. Now up here, we applied a chamfer to the inner walls so that there is no overhang on the top. And actually, if we were to go back around this, we would probably rebalance it so that the top was the same thickness as the base, and it would basically look like a pillar that could be turned upside down. That would be a really cool way of going about this lamp, so you can use industrial design to create all kinds of new capabilities around the restrictions that are available. But this eliminates the overhang so that you don't have a kind of nasty upper part while still having the transparency on the side, where again, it's about 1 millimeter thick, and then you have the solid base on the bottom that the luck is able to go into in order to light this lamp up. This is one single print. It's very fast, it's very efficient, but again, a texturing. Apply a little bit of texturing to the outside, and then you can add different patterns. You can use a logo if you want to, and then you can eliminate any sort of artifacting, because artifacting will always be a problem. 3D prints have shrinkage and growth and all the rest of it. This part, when the light is turned off, shows a small wrinkle around the top that is not very seemly, and that is something that you want to watch out for because it can create a bad experience when the light is not turned on. But again, we wanted to highlight them inside of this video so that everybody can see what could go wrong if you don't actually use it. But this lamp brings up another great example of ways to create kind of a new sort of aesthetic. Since 3D printing is able to create impossible geometries, you can create internal patterns that aren't viewable on the outside, to where again, it looks smooth and white and monolithic, but as soon as you turn on the light, you see whatever is presented on the inside. We've talked about this before, where you can use translucency to create all kinds of nifty capabilities. You could put a special message inside of there that no one sees until they actually light the lamp. These are all really cool capabilities that have never been possible before, but now you can create a really, really unique product that never really existed. So hopefully that made clear some of the things to be aware of when designing lamps. You want to use the same profile throughout because creating fully monolithic lamps is totally possible. We've produced a negative, and of course we have designs of the puck available. So you can actually design your own lamps, and then you can just upload them to Teleport, and then when somebody orders it from your store, we will print it, include the puck, and ship it straight to your customer for you so that you can start up a 3D printed lamp business basically with no startup at all. Just design the lamps and upload them. It's a really cool capability, but you need to watch out for the seam, make sure you're applying textures to the outside of the parts whenever possible, unless you want the 3D printed look and are using that intentionally, but then also watch out for your overhangs so that you have the light go where you want it to go. But ultimately, when you're testing it out, just make sure that you're using a 25% infill with a 2-wall thickness, and make sure it's a 0.2 layer height. And then you get a pretty good approximation of what the lamps will be coming out of a service like Teleport. This is a really cool capability. It's never been possible before for people to just create products and then upload them that other people can have and own and feel special. You can create customized items. You can upload thousands of SKUs. It's a really cool capability that's never been available before, and we're really excited to share it with you and share the ways of creating products that can really take advantage of this new technology. 3D printing is able to mass produce all types of different sorts of products, but it is a different type of process, which means that you have to design for it because it's not the same as molding, machining, or any other type of process. What you have to do is consider how 3D printing works and then create the product that you want to make. And if you do that, it allows you to create something completely unique and differentiated from what has ever been made before. So let's go ahead and take a look at this tape dispenser. So a tape dispenser is a really mundane type of item. It's very low cost, it's very common, everybody has to interact with it, and everybody understands what it is. If you look at a standard type of tape dispenser, you have to have something sharp on the front to cut the tape, and then you want some sort of weight so that it actually sits on the table and is reliable. But so many tape dispensers made today are just gross. They're black, terrible, U-shaped, nasty things that don't make your life that much better when you're sitting inside of your cubicle. But what if you could add some color, some texture, and some vibrance to something so mundane? 3D printing lets you do this by creating a number of features that are really interesting. So when we were designing this, the first thing we started with was a standard brick. And once you had the brick, you're like, okay, cool, that's fine. You could actually turn that into a tape dispenser and it would work fine. But we want that sharp edge on the front. So in order to get to that, what we did was we angled the tape dispenser. This way you end up with this sharp edge at the front that you're then able to cut the teeth out of. Also, from a CAD perspective, this makes the operation really simple because those serrated teeth are able to just be a straight extrusion without some kind of wonky angle, but they end up fading off of the edge and looking really cool. The angle itself also helps to give it a little bit of proportion, and also from an industrial design perspective helps show you the point of action. It leads your eye to the point so that you know, oh, that's where the tape actually is. The overall shape follows standard 3D printing practices where we used chamfers in a lot of places, especially for the outer edges, because they just look good and they eliminate any sort of like elephant's foot and that kind of thing when mass producing these, because you always want to eliminate any sort of options for failure inside of a 3D print as often as you possibly can. 3D printing also let us do this all as one single unit. There's no assembly at all. We're able to print this brick all at once and it's completely finished. Whereas traditional tape dispensers are generally produced by two halves stuck together with some sand in between, and then you screw on the metal blade on the front. But this is all done at once. What we did was we actually print it upside down like this on the print bed. Using a glass print bed, it allows us to make those teeth very sharp so that you can actually cut the tape on them. And we're able to have the channels inside of there be printed because even though it's kind of a difficult, if not impossible, geometry to make any other way, you can actually embed them in there and it prints fully complete. We also used a higher infill, so this part is naturally heavy just from the nature of the plastic itself. What you can do though, if you're really optimizing for cost, you can make it lighter and fill it later on, but this makes a really premium feel part because this weighs about 1/4 pound or so, which is a nice bit of heft to feel really, really premium. The other thing we did was to the outer side, we used a bit of noise. We added some noise to it and added this texture, which is a very expensive type of feature to do with other manufacturing methods, and also just softens it up so it looks beautiful and you don't really see layer lines. And the last feature that's really special about that is just how thick it is. This type of part, this chunky, thick, heavy part, cannot be made unless you're carving it out of a block of wood, which means that you're now wasting a ton of material, whereas with 3D printing, you're able to make a thick, chunky, heavy part without waste and without having to worry about things like shrinkage, which make this type of a piece impossible to mold because the sides would warp and shrink in if you were trying to shoot that much plastic into a place. Now the housing is all fine and interesting, but one of the most fascinating parts of the design of this is actually the roller itself. Round parts don't like to be printed, and in this case the round part had to be printed horizontal so that the spokes were actually strong and reliable and you didn't have to worry about layers breaking. So what we did was we modeled up this hub the way we wanted it to, and you have the two spokes and everything. You go ahead and fillet it all so that it's as rounded as possible on all of the sharp edges, but then the clever little thing that we did was we actually cropped off one side, giving it a single flat edge. Now that's pretty simple. And doesn't have any effect on the function of it because again, it's going to go into another circle and having a single cropped edge doesn't really affect any part of it at all there. But this does make it very printable because now it has a nice surface to print on. But now you have the issue of these actual overhangs over here, and we can't fillet or chamfer those. We can't do anything terribly clever with it because those need to be able to sit deep into the grooves of the main body. But what we did with this was a little bit interesting that people don't often do. We actually designed the supports into this. The way you make a designed support like this is you make a little pointed tower, and that pointed tower has an interface point of 1/2 millimeter, just 1/2 millimeter. That means that when you print this, you have towers exactly where you need them. There's no excess material. You don't have to worry about tweaking settings or anything like that. It is perfect every time. And when they're finished, they just snap right off and there's nothing to have to worry about. It's very easy to process. This part, when it came off the machine, if we were making 10 or 100,000 of these, you'd basically just throw these all into a tumbler and the supports would fall off. So it's a very efficient way to make support for a very trivial little feature so that this part basically comes off a machine fully complete and ready to go into a box, which means that you can now make it very, very affordably, because anywhere you can eliminate human labor in the production of a product, you want to. So the tape dispenser was actually a more complex and subtle type of part than many people would really realize, because when you're designing for 3D printing, there's a number of different rules to follow and a number of different tricks that allow you to create something truly unique and different from what exists anywhere else out there, but still affordable, reliable, and mass producible. So this coffee maker is a very simple design. It's a simple curve, but even though it is a simple design, there is a lot of subtlety within it that is really educational about how to design a product. Number one, it is a coffee maker, which means it comes into contact with coffee. Generally inside of 3D printing, we recommend combining as many parts and pieces as you possibly can, because with printing, you can turn complex assemblies into single monolithic parts. But here in this case, we want to make sure that the product is good and sustainable and long-term. So using a third-party part is fine. This main filter at the top that then can hold your paper filter is the way to add a little splash of metallic to it, but also improve the functionality of the part. Now, this is a minimalist maker, which means we wanted to use as little material as possible. Again, 3D printing gives us a huge benefit because you have all of this hollow feature over here on this side that has a very low infill of about 3 to 5%. That lets you use very little material while still having good structure and a good proportion. Because if we made this like super thin, it would just look weird and wonky. This chunky style, while still minimalist, makes it look like something robust and something reliable that you can have around. So when we designed it, we wanted to, again, make sure it was strong and reliable and didn't have any sort of supports. Now, on a lot of times on this channel, you'll see us say, oh, print it just like this at an angle, that way you don't need support. But that doesn't really work in this case because we wanted this rounded outer shell and this beautiful texture and all the rest of it. So we had to print it on its side. When printing a part on its side, it's important to be aware of the bed surface. So this part was kind of led along in its design to have this really kind of sharp chamfered edge that comes down to almost an 1/8 inch wide seam. This means the bed surface doesn't really impact the look of the part because the bed interface spot is so small, because it's this little seam over here and this little seam over here, you can't really tell the difference between the top and the bottom. That minimal bed contact area also allows this fairly large part to be mass producible because it doesn't require manual removal. It's not stuck to the bed so terribly that someone has to pull it off. The machines are able to eject it and move on with their life that way. So you have a lot more scale with this part to where it can be produced affordably. Now, in the bottom, there's all of the kind of design accents that we did of, yes, the beautiful curve, and you have the detent in the bottom for the cup, which implies that's where you place your cup. But let's go ahead and talk about the top right here. Again, this is being printed on its side, so you have to be aware of the overhang. You don't want to have a saggy top and you don't want to have any support. With this first prototype we did, we actually have kind of a rough side over here compared to the smoother side on the bottom down there. That's less than desirable, but survivable for a lot of products if you're doing kind of small run stuff. And that can be addressed a little bit in post-processing. But if you were going for full print on demand, it is best to have design support inside of there to make sure that it's as tight and beautiful as possible. Now, looking at these teeth come in from 4 directions. Now, normally something pointing down at an angle like this would need support itself. But what we did with that was actually create these overhang supports underneath here and chamfer them so that they come to a point, but at kind of a weird oblong angle, which is then mirrored on the bottom so that you can't really tell that it was intentional. Otherwise, you would have, I don't know, some chamfer at the top and then normal spikes down at the bottom, and it would just look weird. But by creating this symmetrical geometry, you're able to get the points that set the filter off from the printed part, because when this is plugged into the top, wherever this touches the plastic, water and surface tension is going to pull liquid that direction, which means you could get leaks around the side of the hole rather than around the tip of the filter. So having those points and having those points guide liquid down, make sure that all the liquid goes to the point of the filter so that you have a smooth flow that's not really contacting the part. And of course, as far as texture, we went and added just a little bit of noise to it to make sure that it looks really beautiful, and we use this wonderful kind of terracotta color that just looks nice for a minimalist thing. Right now, if you would like to get access to this print, we have added it to the catalog of our Etsy plugin, so you can get a hold of it and add it to your Etsy store over there if you want to. It's a very beautiful design, and most people will have one of these filters available that they can just add in the top. So it's a good example of how to create a mass-producible product that's both very efficient, functions really well, while still having the proportions and thickness that it needs to look good. Whereas traditional processes just wouldn't allow you to create this type of geometry and do it economically and reliably all the way through. So hopefully you learned a little bit about mass production 3D printing. If you would like to see another version of a coffee maker that we made, go ahead and check out this video where we go for a chunkier type of aesthetic, and there's a number of different design considerations on that one that are completely different from this minimalist design. Have a great day, everybody.